Hello and welcome everyone to Building SaaS on AWS, the AWS SaaS Factory's Twitch show for builders of SaaS here on Twitch. My name is Anthony McClure and I am a solutions architect with the AWS SaaS Factory and your host for today's show. If you are currently a builder of software as a service solutions or are just beginning to get started on your journey learning how to design, deploy, and build software solutions in multi-tenant environments, then this is the show for you. In every one of our episodes, we strive to bring you experts in the field of software as a service that can dive deep into the many facets of software as a service and help you to learn how to deploy your own applications onto AWS. And today's episode is no different. In today's episode, we will be diving into the rather interesting topic of networking and routing as it relates to SaaS. And in order for us to do that, I have with me several of my colleagues from the AWS SaaS Factory that can help us to dive deep into that topic. First, I'd like to bring on to the platform Mr. Peter Yang, and next, Saeed Hussain. Welcome, both of you, to the Twitch show.
Thanks, Anthony. Hi, everyone. My name is Peter. Like Anthony said, I'm a partner solution architect with SaaS Factory as well. For those who are not familiar with SaaS Factory, we're a specialized team here at AWS, and we're a team that consists of solution architects and business architects that's working with companies who are looking to create a new SaaS solution on AWS or transforming an existing application running on-prem into a SaaS solution running on AWS. So we get to work with partners and customers every day that are looking to create SaaS solutions. Syed?
Thank you for that. Yes, Syed, want to introduce yourself?
Sure. Hey, everyone. My name is Syed Hussain. Like Anthony was saying, I'm also part of the AWS SaaS Factory here, and I work on sort of on the partner solution side, helping customers build SaaS, helping partners build SaaS on AWS, coming up with thought leadership and sort of kind of providing momentum behind the movement. So I'm pretty excited to be here, and yeah, I'm excited for the show.
Absolutely, yes. Welcome to both of you, and thank you for being here to discuss this pretty important topic that honestly probably doesn't get as much airtime as many of the other features of SaaS that we like to talk about: tenant isolation, data isolation, onboarding, all of these features. We talk about that quite a bit. But this really fundamental topic of networking is, I would imagine, very important and has some specific SaaS implications as well. Is that true?
Yeah, definitely. I think a lot of times, I think you're right on. A lot of time when we're talking about SaaS, we're thinking about isolation, we're thinking about compute or storage, right? So we don't really talk too much about how does a request actually get to the right workload. So I think today, kind of focusing on the networking aspect, how to route that request to the right workload is something that we don't typically talk about. So really excited to have the opportunity to talk about it.
Awesome. Yes, thank you. I also want to give just a quick shout out also to all of you that are joining us here live on our Twitch show and in our Twitch and YouTube comment section as well. If you have any questions or comments for myself, for my guest, please feel free to add those into the Twitch chat, and we will try to answer those as soon as we can. And while you're in there, please feel free to say hello to Bill Tarr, who is our colleague, and acting as moderator today as well. Also, give us a shout as far as letting us know where you happen to be, where you're joining us here today. But without further ado, let's jump into the topic at hand. So, how do you frame this problem, or what is the kind of the crux behind why we need to focus in so much on networking and routing?
I think about network and routing, at least today's topic, kind of based on isolation, right? So like we said, we typically talk about compute and storage, but if we're to take a look at SaaS and think about SaaS isolation or delivery model for SaaS, typically we have two types of delivery models. We have a pull delivery model and we have a silo delivery model. So a pull is where tenants are sharing the same set of resources between other tenants. And then a silo is when each tenant has their own isolated infrastructure and resources. So, and not when we typically think about SaaS, when I'm working with my partners, I'll remind them, don't think about SaaS as a pull model for my whole SaaS solution or a silo model for my whole SaaS solution. Think about them as different microservices, and each of the microservices is a piece of the puzzle. So that each piece of the puzzle can be a pull solution or it can be a silo solution, really depending on where your sensitive area is, or what your customer is looking for, what the SLA strategy is going to be for the SaaS solution. So, Syed, if you want to throw this slide up, or Anthony, I'm not sure who is controlling
that
this.
started here. There we go.
Yeah, thanks. So here you kind of see the depiction of the silo and then the pool, how they're shared. And if you go to the next slide, and this really start framing in the conversation that we're going to have today. So if you think about the fact that you have pulled and siloed deployment model in your SaaS solution, when a customer is bringing up a browser and typing the URL, how does that request go from the customer's browser to the right workload, whether it's going to be pulled or siloed for that particular tenant? So you see the question mark there that we're going to be highlighting. And we have an auth here. So we have a identity provider that's doing the authentication with a security aspect of SaaS. And really, when I think about SaaS, I think about authentication in with two different purposes. One of them is proofing you are who you say you are, authentication, username and password. But the other purpose that we have in IDP in the equation here is that we rely on the IDP to tell us about the SaaS identity of the user. And the SaaS identity is who the user is, a combination of the user identity as well as a tenant identity. Not only does the SaaS identity tell me who the user is, but it also tells me which tenant does the user belongs to. And then the IDP will issue a job token that contains the SaaS identity. And this job token is going to be utilized by the SaaS solution as we determine the routing options. And where to go with the workload.
When you're talking about the IDP here, or the identity provider, in the AWS world, this would be like Cognito, for instance, right?
Correct. In the AWS world, it would be Cognito, or there's other IDPs out there that we commonly see, Auth0 and whatnot. So if we think about the routing pattern, like how we get from the workload into the SaaS, we typically think about it, at least when Asaya and I were working on this, we think about it in 4 different patterns. The first pattern will be DNS to load balancer to service. So DNS obviously is how the user is going to be accessing the SaaS solution. And then what do we put between the DNS and the service, the actual compute or the SaaS solution that's running in our AWS account. The next one is going to be DNS to API gateway to service. And we're kind of swapping out load balancer for API gateway. And in the discussion today, we're going to talk about why we do that, when we do that, and what are the use cases for using an API gateway rather than a load balancer. And the next one will be DNS to API gateway to service to storage. We keep on talking about isolation. It's about compute and storage. So here we also want to cover how do we get from the service to the storage. Keep in mind that I said each of the microservices like a piece of puzzle. So even though you can have a pulled or siloed microservice, that siloed microservice, that pull microservice can be talking to different data store as well for the different tenant isolation strategies. And then last one is going to be DNS to CDN to service. Obviously, when we're building a SaaS solution, we want to think about growing our business. We want to think about expanding it. So when we think about where our users are going to be, they may be in different regions of the world. So how do we utilize CDN to deliver that solution to be closer to the customer so that we can have better performance? So that would be one of the patterns that we're going to be covering today as well.
I would assume too, in looking at those 4 patterns, that there is obviously possibility here that they could be combined together as well, right? You could have different combinations of these.
Of course. And then, we did our best to try to identify the major categories. There's obviously going to be different permutations or different combinations of them. So it's not going to be an exhaustive.
It always depends, right, in SaaS.
There we go. That's the standard essay question. It depends. So yes, there's going to be different combinations versus highlighting some high-level categories that we see. And then even on the next slide, these are just going to be puzzle pieces that we think about. And there's definitely going to be other services that you can utilize as well. But these are just kind of a demonstration in terms of the common service that we typically think about. But again, not a complete list by any means.
I noticed that there's some integration pieces here too that are pretty important when we're talking about working with, say, EKS or Kubernetes and containers like Istio or App Mesh as well. So they can ultimately play a role.
Of course. And then not all services, like you said, like you're highlighting here, Istio is not an AWS service, but it's something that we commonly see within the SaaS solution as well. So this is not the discussion today. We're going to be talking about Istio. So now we're not going to keep it exclusive to AWS service, but it's just going to be common patterns that we see when we're working with customers and partners. Cool.
Awesome. So thanks for the sort of the intro in terms of the patterns that we want to discuss during this time that we have together. I just want to say it's pretty exciting to be here on live. I mean, on Twitch, because I was just kind of distracted by the comments coming in and reading through that. But it's pretty cool. This is my first time, so it's a good distraction. But, for the rest of the show, I'll endeavor. Sorry, go ahead, Anthony.
Yeah, of course. No, we love having new folks on the stream, and you are absolutely welcome, Saeed. Thank you so much for being here.
Awesome. All right, let's quickly get back to the discussion here. So the first pattern that Peter talked about was going from DNS to load balancer to service. So let's just put some of those puzzle pieces together and see what that looks like. So the first one that we have here is the DNS that we talked about. In this case, we're going with the silo DNS approach, and basically what that means, in kind of real life or practical terms, is you would end up with records or DNS records that go like tenant1.example.com, tenant2.example.com, an example being your SaaS application or your SaaS provider.
So basically like a tenant per subdomain.
Exactly. That's exactly it. Yep. And the technology for this, we'll just go with Amazon Route 53, but there's several different options out there. And then on the right hand side, you have sort of the target. In this case, it's going to be a set of Kubernetes pods, within a deployment backed by a service, that kind of stuff. So a set of workload deployed on Kubernetes. And the technology of choice, again, stored, it's all sort of contained within a VPC or a virtual private cloud, and then running on an Amazon Elastic Kubernetes service or EKS. And then the load balancer that we talked about, right? So in this case, we're going from a siloed DNS, so tenant1.example.com, going into a pool load balancer. And really all we're saying there is that all of those different tenants, tenant1, tenant2, and so on and so forth, whenever they hit their kind of siloed DNS, they are routed to the same pool load balancers. Basically, multiple tenants are using that load balancer, as opposed to the siloed DNS, where only tenant1 is using tenant1.example.com. Go ahead, Anthony.
No, I was just gonna ask. So this would be like a network load balancer or an application load balancer on the AWS side?
Yeah, exactly. Right now, we're going to go with the network load balancer, as that kind of suffices for this use case. But you'll see it later on as we swap this out for an application load balancer, for example, when we need to. And then what this network load balancer does is it routes a request off into a pool gateway. And in this case, we decided to go with Istio just because it does provide some of the advanced capabilities. But again, you're free to sort of swap that out for whatever makes sense. And we will do that, as this discussion sort of progresses. And then what would happen at the end is, the pool Istio gateway through this sort of the virtual services and the configuration defined, it would route the request off into the specific workload that's for it, right? So there are a couple of ways that you can do that. One is kind of viewing information within the request, and we'll look at what that looks like in just a second here. The other is, viewing information within the JOT itself, which is really powerful because, as we all know, the JOT or the JSON Web Token is cryptographically secure, it's tamper-proof. So once it's been sort of stamped out or minted by the IDP or the identity provider, as long as it's valid, then you're able to kind of trust the claims that are within it. So using those claims, those verifiable claims that are within the JSON Web Token, it makes a lot of sense for us to rely on that information for routing purposes, right? So if we open up the JOT, we find that the claim in there indicates that it's for tenant1, then we know for certainty that this is tenant1's JOT token, and we're able to kind of take that and route it off to tenant1's workload. So that really helps in that case.
For those that may not be familiar, that JWT or JWT token that Syed is referring to is typically provided by the identity provider. And that identity provider, when building a SaaS solution, typically has the ability for us to add what are called custom claims or custom bits of information that help us to identify the user to the tenant, that tenant identification that Peter spoke about a few minutes ago.
Yeah, so thanks for pointing out, Anthony. The custom claim is really what we leverage to Incognito today. At least is what we leverage to build that SaaS identity that I mentioned earlier. And I talked about the different puzzle pieces, right? So we talked about the way I kind of view it is that each microservice is going to be different puzzle pieces, and they have different storage as in one of the later categories. But sometimes we also need to talk between service to service. Right, so like if you think about your SaaS solution, it consists of different microservices. One may be more sensitive to than another. Like in an online e-commerce website, a product catalog service may be something that we can utilize as a pulled deployment model, and then the invoice or the order service may be something that we're going to be siloed. So, Syed, any guidance here, like in terms of service to service routing?
Yeah, that's a good call. I mean, unless you're making kind of a toy or trivial application, it's likely that you're going to have your workload, your services broken up into layers. Some of which are maybe customer facing, some are internal that are used by other services. So in that case, the guidance or what I would kind of suggest is let's look at what that might look like in sort of an EKS kind of context, right? So we have that EKS cluster that we originally talked about. I put a Istio sign there just to indicate that this has been configured with Istio. And then, you have a pooled namespace. Here you have a pool service one, let's call it. And again, just to bring in kind of Peter's example here, this could be some sort of a service that's maybe not as sensitive. Something like a product order service, which I believe is product service, which I believe is what Peter mentioned there. And then you have some sort of a service in kind of your internal sort of landscape. And this could be some sort of a maybe more sensitive service, like an order service that processes, or an invoice service that processes payments maybe. And just one more point I want to kind of indicate before I move on. And because this is, Istio is enabled here, we have these Envoy proxies that are added as sidecars to our different pods. And really, they are kind of the piece that helps us with routing issues, monitoring, observability, that kind of stuff.
And that's a part of Istio, correct?
Exactly. It's not something that you yourself have to sort of maintain. As long as you're maintaining your Istio and you configure it correctly, that should just work. But when you're trying to get from pool service 1, for example, to pool service 2, if it's just a one-to-one mapping, then it's relatively straightforward. You can use, for example, like an environment variable that you sort of plug in at deploy time, and you're ready to go, essentially, right? You have that endpoint, and you're able to make requests out that are coming in. But what it's tricky is when you have sort of maybe another workload, for example, in another namespace, you have a siloed version of service 2, or siloed version of the invoice service, for example. And this is dedicated just for tenant B. This could be sort of a tier offering that you have, saying that for customers that want that extra layer of isolation, that extra layer of protection, we offer this advanced tier at a cost, obviously, that provides this sort of dedicated, isolated kind of version.
Their own infrastructure, basically.
Exactly. So now the tricky part comes in, where multiple tenants, so tenant A, tenant B, tenant C, and so on and so forth, they're all talking to pool service 1. But now when we want to talk to sort of the downstream services, we want to ensure that we kind of maintain and respect that level of isolation, right? So we don't want, for example, tenant B's request to pool service 1 to cause us to make a request out to pool service 2, right? So we want to make sure that we kind of respect and maintain that level of isolation. So what we need to do is essentially figure out a way to have tenant B's request, and only tenant B's request, go out to siloed service 2. And the way to do that in Istio is using virtual services and dictating one host, which then you use via virtual services to sort of route requests based on headers. So you have the exact same endpoint. So pool service 1 is always hitting the exact same endpoint, But based on the headers you've configured, pulling that from the JOT or the JSON Web Token, as we talked about, allows Istio to come in and kind of be the middleman between the pool service 1 and the corresponding service, and appropriately route the request. And one of the really nice things, and just one point before I kind of move on here, that one of the really nice things about this is that your developers, maintainers, they don't have to worry about that sort of complex routing information or anything like that, right? All they do is they make a request out to the exact same endpoint every time, and it's Istio in the background that's sort of taking care of that complexity. And that's really an important point that we try to advocate for a lot here at the SaaS Factory, right? Basically taking that burden away from your developers, right? They should not have to know that I am now serving a request from tenant A versus tenant B, and so on and so forth. So to the extent possible, let developers focus on what they do best, which is writing business, focusing on solving business problems, right? Not solving complex kind of routing problems. So that's just one point right there I wanted to make.
Yeah, that's something maybe that people don't necessarily think of right out at the gate, right? When we think about networking, we typically are thinking about the infrastructure level within AWS. How do you route the request from the internet into the AWS account, ultimately reaching the services or the compute that we're looking for or the data? But when we're dealing with containers, especially, there's the inter-container networking that is just as important, right?
Exactly.
So having a tool like Istio or another app mesh routing solution within the EKS cluster helps to abstract that away from our developers and what they have to do, correct?
Yeah, for sure. Cool. So let's kind of get away from that rabbit hole and just come back to the original discussion we were having here, right? So we had kind of, just to reiterate real quickly, we had silo DNS going to a pool load balancer, going to some sort of a gateway like Istio in this case, and Istio was routing requests off to sort of dedicated workloads within a single EKS cluster. This could be by namespace, for example, so multiple namespaces per tenant. But now let's change that up a little bit. Let's consider the need, for example, like we talked about the need for isolation, right? Let's say that we create a new tier where we offer to customers saying that, we'll go ahead and not only isolate you at the cluster level, but also isolate you at the VPC level. So not only are you not sharing the same cluster as other tenants, you're on a completely different network, right? So that might be sort of a strong motivator for some customers that maybe have regulatory requirements and need to have sort of isolated workloads, right? So what does that look like if you were to kind of implement that using some of the pieces that we have here? Well, obviously you wouldn't be hitting the same EKS cluster. Now, what you would do is essentially you need to connect different VPCs, because while we've shown the Istio gateway, the pool gateway kind of on its own, it's really part of the same EKS cluster in the same VPC. So now what we need to do is somehow attach these two different VPCs, one VPC containing the pool Istio gateway, one VPC containing the tenant's workload. Right. So now we need to figure out how to sort of connect these two VPCs. And one option for that is, using a VPC peering connection. So what that would look like is now Istio would, communicate over that peering connection using the endpoint for that tenant. And then via that peering connection, they would find and route the request off to the appropriate EKS cluster containing the tenant's workload. Does that all make sense? Go ahead, Peter. Sorry.
Yeah, I was going to say with the VPC peering is a good solution, but really depends on the architecture and what your growth is going to be. So a lot of time when we're talking to customers and partners who are building a SaaS solution, we ask them like, hey, where do you see yourself 6 months from now, 12 months from now, 3 years, 5 years? How many customers are you going to have? So the gotcha with the VPC peering is that you have to really plan ahead, because you have to deal with the potential overlapping CIDR ranges with the IP address between the VPC, right?
Yeah, a lot of planning has to go into the overall network layout at that point, right?
Yep. And then also keep in mind that when you do a VPC peering, you're exposing all the services within the VPC. So you really got to think about what are you going to be putting in that VPC, because essentially they're all going to be exposed through the VPC peering.
Yeah, that's a good point. I mean, it's not, it's not obvious, always possible or even obvious for us to kind of predict the future, right? But that's really kind of what we're asking, or do the best you can, kind of a thing here. Which basically it really helps to kind of have that foresight, right? Like, I mean, if you know that you're only going to be serving maybe a handful of tenants that require this kind of configuration, then what we have here is perfectly fine. But then, if, like Peter said, you're looking to onboard maybe hundreds, thousands of tenants in this fashion, then VPC peering might not be kind of the right approach. So what could work here is looking at something like private link, right? So one of the nice things about using private link is that not only are you not sharing the entire VPC, but you don't have to worry about overlapping CIDRs as well. So it's a little bit more secure. You're only kind of accessing what you need to. And then you also don't need to worry about kind of, what it looks like when these two VPCs appear together and you have these overlapping CIDRs or overlapping IP ranges. So with the addition of a private link, what happens is that Istio makes a request out to that endpoint, and via a network load balancer, the requests are routed to the EKS cluster and to the workload that's running within that EKS cluster. So that's how we kind of solve that problem.
Yeah, then private link is you can identify the service you want to expose, and then making sure that you only expose the service that you want out of that VPC instead of the overall thing. But say, let's take it one level.
Much more directed, right? Much more directed, a bit more secure in that aspect as well.
Mm-hmm. So let's take it one step up. So we talked about the service, we talked about the VPC, but isolation at the account level.
Sure. Yeah. I mean, so at this point, one of the things I would kind of bring in is VPC lattice, right? And that might not be something that's front of mind for a lot of folks, given that it is a relatively new service. But it's really powerful in that it allows you to sort of connect different VPCs. It doesn't even have to be kind of, like Peter was saying, have to be on the same, AWS account. It could be sort of across AWS accounts. And not only that, I mean, right now we're kind of looking at, Kubernetes pods, and VPC lattice definitely supports that within the target group that it offers, or that you can set up using VPC lattice. But it also supports other types of compute. Like, for example, we're going to be looking at serverless or Lambda functions. And VPC lattice target groups can consist of Lambda functions as well as Kubernetes pods. So there's a lot of flexibility that you get when you introduce something like VPC lattice. But the idea would be that you'd create a service network, you'd add on these VPCs that you want to connect, and then you're good to go. All you need is the endpoint, and you're able to connect to the different workloads that you need to access.
Is there any particular reason why you would maybe suggest to somebody that they should use VPC lattice versus private link, let's say?
I mean, one of the things is, like Peter was saying, right? You want to get to maybe different accounts as well, and then also there's other benefits of VPC lattice as well. I mean, the kind of the hierarchy that they've developed, with a service network owner that kind of defines all of these different connections, and then the ability to kind of take these different services that make up your service network and sort of handing their configuration and handing their development and setup off to individual teams allows you to kind of scale a lot more easily. So that's definitely something, is for large enterprises or even small, kind of shops. That's definitely something, you want to check out. Again, it's a relatively new service, but it seems very promising. So definitely check that out, especially if you have kind of a complex sort of a networking environment.
Excellent. Thank you very much for that. And before we jump any further, just to talk back to our community that is joining us here live today, you are currently watching Building SaaS on AWS. My name is Anthony McClure. I am a solutions architect with the SaaS Factory, and we are joined today with Peter Yang and Saeed Hussain, also from the AWS SaaS Factory, and we're discussing networking and routing in SaaS solutions. And again, if you have any questions or comments for us, please feel free to add that into the chat, and we will try to get to those as soon as we can. Saeed, back to you.
Awesome, thank you. And I'm just itching to. I see 13 new comments. I'm just itching to check that, but I know we gotta focus on the content here and the discussion happening here. So I will worry. Awesome. So that's kind of the discussion there. But let's kind of change things around here, right? I mean, we originally went with silo DNS, And that really afforded us kind of the tenant context that we needed right at the front, right? I mean, tenants were telling us, who they are in maybe not in a secure way, but using about
Right. It's right part of the
using
URL, right? Part of the
exactly,
URI.
it's right in the
Okay,
URL.
we know.
So that really helped us with the routing kind of side of things. But let's sort of flip that a little bit, right, and go with some sort of a pool DNS. And what that means, kind of in practical terms, as you can see there, is instead of that tenant information or that tenant kind of hint being provided right at the URL, all of our tenants are now using the same endpoint. So that information is now not as readily available. And just kind of flipping to the right hand side, the target workload. In this case, we're going with a
Serverless
set
in
of
this case.
exactly, just to keep things interesting. So you have these siloed set of Lambda functions here as well. And then, as I was talking about, because we no longer have that tenant information right at the front, we need to sort of pull in a more sophisticated load balancer that operates at a higher level in the networking layer, because we now need to, for example, do routing based on headers and requests and that kind of stuff. So that's why we've kind of instead of the network load balancer, which operates at a lower layer and doesn't have that access to that kind of information, we're now using an application load balancer so that we can rely on header information, path information for for example for tenant context.
It's basically changing our routing from layer 4 to layer 7 in the transport protocol.
There you go. Exactly. So now instead of instead of kind of everyone using maybe the same path or the same headers, for example, now everyone can use a different path. For example, if they need to access their dashboard, they would be instead of going to example.com, they would go to example.com/tenant1. And then the application load balancer could look at that path information and then use that to kind of help route requests off to individual workloads.
And just because we're all SAs, just if we go back to that previous slide, the it depends response that we typically give. So like ALB, NLB, we talked about the different type of load balancer. They're all good solutions, but I'll kind of come on going back to the point. You really have to think ahead in terms of where you're going to go with this SaaS solution. So with an ALB, you have a limit in terms of the number of target groups that you can have. If I think I'm going to have large amount of tenants, or I'm going to have the ALB routing to different type of services, just keep in mind that there is an account limit of 100 target groups for ALB. That's not configurable, or that cannot be changed. That's a hard limit.
Very good point.
So it's just kind of to plan ahead and say, I think your next step's going to say, hey, if I'm going to be pushing against that 100 target groups, what's the name of the option?
Yeah, that nicely cues up kind of the next sort of puzzle pieces that we're going to introduce here, right? So again, keeping that same DNS and keeping it pooled, so we still have that that sort of complexity. And then on the right hand side, we have the Lambda services that we want to talk to. But like Peter was saying, we now are going to kind of swap out the load balancer with its limit of about 100 sort of target groups. And switching that off into an API gateway, which can support, starting at 300 different kind of destinations, right? So, depending on your path, it can support all of those different, much more tenants, much more tenants and destinations compared to the load balancer. So what would happen is that, sorry, Peter, just one point I want to make here.
Go ahead.
One point, what would happen here is that the pool DNS will route off to the Amazon API gateway. So example.com would take you to that Amazon API gateway URL, which again is used by all of your tenants. And then based on information, for example, within the the header, so maybe it would be like tenant1/products, and then that would be kind of your header. And then that would help, Amazon API Gateway automatically route the request off to the
path-based routing in that case.
Essentially, exactly. Sorry, Peter, I think I cut you off. What were you saying?
No, I was going to just say the 300 the 300 routes for the API Gateway. That's also a soft limit, so that's something that we can adjust through the accounting, through support at AWS. And then again, I'm going to just kind of sprinkle in the different account limits as we go, just because every service we think about, there is going to be a limit that we have to kind of consider when we're designing the solution.
Awesome. Cool. So let's now look at the third pattern that Peter talked about. And this one is basically kind of like what we talked about before, but now we introduce storage, right? Because that is obviously something that's important, right? You don't want all of your tenants using the exact same storage, right? Exact same database, exact same sort of object store. There is a need to also make sure that, we're isolated at the storage level as well. So what does that look like, right? So again, we have that DNS that we talked about. We have the VPC. It's got some services. We haven't indicated Kubernetes, Lambda. That's it's a detail at this point. But you have a set of services running on some compute, and your Amazon API gateway is helping you route requests off to these individual services. Now, what we want to do is we want to route a request off to, for example, in this case, we have a siloed RDS instance or a relational database service. And what we want to do is basically route these requests off to the appropriate tenant database. So the way we do that is, first sort of dividing them up by different VPCs. So not all of them are immediately connected. And then because they're divided by VPCs, we now need to sort of, bring in something to kind of connect the two VPCs. So in this case, we're going to bring our old friend private link here and use that to sort of help us connect these two different VPCs here. And the way to do that is you configure an endpoint on one VPC, for example, which is the one that we want to connect off to that contains the services. And then through that endpoint and through that private link, we connect off into the RDS using a network load balancer that gets placed in the middle. And the reason we have that network load balancer is to help us as private link kind of connects to network load balancers. So that helps us kind of route the request off into the database, since that's sort of specific for our tenant. And sorry, could you go ahead?
No, I was going to say, just this is kind of taking that database isolation to the next level, right? A lot of time when we talk about database isolation, most of the conversation I have with customers is like, hey, how do we isolate the data or the top partition on the table? Mm-hmm. So I think this is kind of like, we also run into conversations where we hear that, hey, our data is going to be sensitive. We need to make sure that we're further isolated, so that just the fact that your RDS is running in different VPC, that's just an additional layer of isolation. And then I'm kind of curious, I'm going to just poll the audience a little bit, like how many of you guys actually do this within your SaaS solution, or like have seen this as you're building SaaS solutions out, to put a additional layer of isolation on a database running a different account, different VPC? I'm kind of just curious as well.
Yeah, if anybody out there is currently separating or doing their isolation story in a similar way as this, chime in to the chat. Let us know.
Awesome, cool. Yeah, I mean, if anybody kind of chimes in, we'd love to hear it. But we'll kind of keep going, just in kind of save time here. Okay, so cool. So we talked about private link, but let's consider what other options we have here. And one other option here is, again, that peering connection that allows us to connect these two different VPCs. And now again, as we've talked about, basically your services would, using that VPC endpoint or using that peering connection, using that basically the RDS endpoint is essentially, because now the two VPCs are connected, it can directly. You need to use VPC pairing for this, right? I guess I would.
The comment came right. The comment came in right as you pulled VPC peering.
Oh, gotcha.
Bring it up, but it is important to note that VPC peering isn't the only mechanism for doing this, right? Private link that Saeed had up just a moment ago could accomplish this as well.
Mm-hmm. And then it's just kind of like go back to that planning ahead, right? The security aspect of it, especially for a VPC running a database, the private link is going to be more specific. If you do the VPC peering, just make sure that you understand, again, what you're exposing.
Limits, yeah, and limits that come along with that as well.
Right, exactly. So it's all about sort of being, kind of trying to predict the future, but knowing that you can, so making your best efforts to kind of account for that, essentially.
Cost is going to be another thing that we consider when we talk about VPC peering versus private link, right? Like I recently worked with a customer, and then they were showing their existing architecture. And we asked them, how do you do this? They're running tenants per VPC. And for them was VPC peering. They didn't want to incur the cost for a private link to have that private link up and running. So they went with VPC peering, which is going to be, in their scenario, more cost effective. But again, it's going to be planning ahead, making sure there's no conflicting side ranges, and they understand what exactly is running that VPC that they're pairing.
Yeah, so in this case, it really pays to kind of do your homework, right, in terms of making sure side ranges aren't overlapping. It can literally save you dollars in certain terms of private link versus VPC peering. But yeah, let's kind of so just kind of adding in that last piece there. But let's move on and sort of swap out our RDS instance for an object store. In this case, we'll go with an S3 bucket.
S3.
So here, there are a couple options in how you sort of organize your tenants within with S3. It could be bucket per tenant or prefix per tenant, which is something that we see quite common and we advocate for. I mean, it helps you avoid having to manage multiple thousands of buckets, right? And then in this case, the way you would connect it is again an endpoint here. And the nice thing about services like S3 or DynamoDB, then they have this option of using a gateway
Gateway endpoint.
Exactly, a gateway endpoint that allows you to access that service without your traffic leaving the AWS network, right? So by kind of avoiding the public network, you're kind of saving yourself and your customers from a whole host of potential attack vectors here. So it's always a good practice to use that. These
good cost savings that comes with that as well.
There you go. Exactly. Yeah, you don't need to worry about, like, for example, issues like egress, I think. So now you're able to, instead of paying for traffic leaving your VPC, you can kind of keep everything in. It's more secure, and like Anthony was saying, it's a little bit cheaper as well. So what happened here in this case is now your services via that endpoint, they can talk directly to Amazon S3, right? And the way, one option to kind of implement isolation here, for example, at the prefix level, is to use something like a token vending machine, right? I mean, and the reason for the token vending machine is, basically the service is there. They don't know, especially if it's pooled, which is, kind of the case that we're talking about. You don't know what tenant you're kind of servicing, right? So it always helps to have something like a token vending machine that you can use to spin up tokens on a more dynamic basis, right? It's not sort of hard coded with your, for example, your execution role if you're using a Lambda, or your instance role, or your or Ursa if you're using sort of Kubernetes. You can use the token vending machine, and Bill, if you have it, it would be great to kind of post that up. And as we were joking about, I don't think that should be an issue for you to find, given that you're the author. So for folks in the audience, you have a rare chance here to kind of ask the author of that sort of the token vending machine pattern, questions directly if you want to. But basically, you would leverage something like the token vending machine to, based on the request coming in, generate credentials that allow you scoped access to, for example, Amazon S3 or DynamoDB, so that there's very little chance of token. There's very little chance of there's very little chance of kind of data being kind of moved around across tenant boundaries, right? So that's one reason why you might want to use a token vending machine here, and then the endpoint to kind of help you connect off into your Amazon S3 bucket. Let's change that up a little bit and add in something called an access point. An access point is basically sort of a kind of an intermediary between you and that S3 bucket, in that it allows a different level of access, right? So instead of accessing the bucket directly, we are now able to, by using this access point and the kind of the policies defined on this access point, we're able to access only a specific tenant's prefix, for example, right? So what you might do is have an access point per tenant, and then instead of talking directly to the S3 bucket, you talk to the tenant's access point. Exactly. Mm-hmm. And then you're able to sort of again use that as a way to kind of help you organize and keep your tenants and their objects and their files sort of separate while using like a single S3 bucket. So that really helps.
This is a pattern that when I talk to my customers, a lot of them don't realize that this feature exists. But I think it's a great option for a SaaS solution to further create that isolation. And not only are you limiting in terms of what you can access with each access point, but the IAM policy on that bucket becomes more flexible, if you will. So if you think about us storing multiple tenants' data in a single bucket with different prefix or whatnot, when we were writing an IAM policy, that IAM policy is attached to that bucket, right? So whatever policy we were writing is going to affect all the tenants, all the customers that's accessing the data. But with the access point, you can actually create an IAM policy and then restrict it to the access point, so that whatever IAM policy you're writing is limited to that access point, to a specific tenant. And also give you the option of creating a test access point to test your IAM policies before you push it across to the tenants into production. So it's just a really nice feature, especially in a SaaS environment, to kind of consider for isolation or even that kind of IAM policy.
Yeah, all these little undiscovered features and services that AWS has. I always love to see them brought up. So yeah, access points are a great one.
Yeah, honestly, it was something that we were learning as we're kind of putting this session together. It's like, hey, what are the isolation strategies available for S3 and access point? And it showed up on our radar. So we learn about these as well as we go.
Yeah, just one thing I want to touch on, Peter, what you said is, because you're able to sort of test out policies using access points, you no longer have to sort of, work directly on the bucket. And as someone who's, maybe made caused bugs in production, I know, I'm sure as others do here.
No, never. We write perfect code. What are you talking about?
Exactly. I mean, it's very valuable having that kind of layer between yourself and something like a production database, or some object or some resource that everyone, all of your tenants are using across the board. So I think that's really valuable to have that there. But just coming back to this real quick, wrapping this up, using the endpoint, the request would go to, via the access point, then it would kind of enter or access the S3 bucket there. So that sort of wraps up that third pattern. Let's look at, the fourth and final pattern. I know we're kind of coming up on time here, so I want to make sure that, we cover these things.
Absolutely.
Awesome. So, the last pattern that we talked about was, DNS to CDN to service. And, for anyone that might not know, CDN is just a content distribution network aimed at kind of getting content, closer to your customers, right? So latency issues are avoided. So what I want to look at here is, having a subdomain DNS. So basically, tenant1.example.com, tenant2.example.com, and so on and so forth. And then one option you have here is sort of creating CDNs or cloud fronts, which are just Amazon's way of creating CDNs. You create them on a per tenant basis, and then all you need to do is just have those tenant specific subdomains route off into the tenant specific kind of CDN, and then what happens from there is that the requests just kind of flow out into the appropriate sort of Lambda or dedicated compute resources that are for that tenant, right? So it's kind of a one-to-one mapping between CDN to the compute resource. Now, in the case of, you might want to sort of avoid that if, for example, you don't want to pay for, because CDNs can get expensive. So you might want to, to reduce costs and to maybe offer a free tier, for example, you might want to sort of combine all of these different CDNs, right? So what you can do is have some sort of a pooled CloudFront. At this point, you're still using subdomains, so multiple different tenants are making requests off into that exact same CDN. But now comes a problem of routing, right? How do you kind of pick the right origin, pick the right kind of end user compute? So one way to do that is using something called Lambda at edge, right? Which is basically Lambda functions that you can encode and have run right at the edge alongside, in the points of presence, right? Where these compute resources are closer to customers. Again, this is all about making, reducing latency and making access quicker and faster for customers. So
Lambda at Edge is another one of those services that is rather unknown, and the question always comes up: well, where would I use this? This is a perfect example of where this could be useful.
Right, exactly, right. I mean, you're able to kind of call on it, and based on the logic there, for example, that it can help you sort of using some sort of a database store or a mapping capability. You can find the right origin based on request information, right? So the request information maybe that includes tenant information. You can use that to map and figure out what's the appropriate sort of what's the appropriate workload that this request needs to be routed off into, so that Lambda can use that and based on that information help you route off to the appropriate kind of workloads and resources.
Yeah, so like
Fantastic.
for me, I'm kind of thinking Lambda at the edge for the fact that it is a Lambda function. Like Saya said, we have access to a lot of the information, the header information with that request. And then using DynamoDB global tables allow us to figure out the routing rules, which origin we need to route that request to based on the tenant identity. And then the other thing to keep in mind with the Lambda at the edge running this kind of type of configuration is caching, right? So we don't have to do that table lookup against DynamoDB every single time we have a request. We want to make sure that we're maintaining a good caching mechanism within that function so that we can do some of the routing without hitting that DynamoDB table.
Yeah, don't want to add any further bottlenecks, right?
Yep, exactly. But this does give us the flexibility of having a pooled CloudFront service that's servicing multiple tenants depending on where we need to go with the workload. So
awesome. So those were the four big areas, right? The routing patterns that we talked about at the very beginning here. We're very rapidly coming up on time. We have about 5 minutes left in the show today. So yeah, anything further, Peter and Syed, that you want to make sure that we hit for our audience before we close up?
Just kind of summarize what we talked about. So we have these four patterns, like we said in the beginning of the show. This is not a complete list. There's definitely ways you can mix and match with those. But we what we wanted to do is that we wanted to say, hey, here's a first scenario, and then the different considerations that you would want to think about. Again, keep on hammering the point that you really want to think ahead, at least the best you can. Like Saya said, can really read into the future. But when I'm creating a SaaS solution, I would ask my customers, what are you thinking? What's your growth going to look like? And that's when I have a lot of impact in terms of where we start with our designs. So we went through the scenarios, load balancer. We said, hey, if we start pushing up against account limits, we go to API gateway, the services storage, and then the CDN for the delivery aspect of it. So hopefully in today's discussion, we kind of highlighted that isolation is not just about compute and storage. You really have to think about how you can isolate that workload, how to utilize that SaaS identity, that JA token, or request headers to really identify which tenant does the user belong to, and how to route to the appropriate workload.
Yeah. And so as we're wrapping this up then as well, where would our customers go to perhaps find or read more about these different patterns and what we recommend from SaaS Factory?
So we have a SaaS Factory Insight Hub that's running on the SaaS Factory URL. Bill, this is your cue to do your magic. So we have the Insight Hub that you can go in and find a lot of the resources, the materials that SaaS Factory has put out. Like Saya said, one of our jobs is to make sure that we have thought leadership and really try to communicate and convey some of these knowledges that we get ourselves as we work with the partners and our experiences into these blogs and presentations.
And if you're more hands-on, sorry, Anthony, just one thing I want to add here. If you're more hands-on and would prefer maybe learning by doing, there's a workshop that we did called SaaS Microservices Workshop, which actually covers some of the patterns that we talked about here. For example, service-to-service routing, right? I mean, we talked about synchronous here. There's actually asynchronous routing, right? And that kind of has its own challenges. And that's something we sort of cover in that workshop. So definitely check that out. And hopefully, Bill, you're able to find that. I know that's not one you created, but I hope it's one that you can find. But yeah, so if you're more hands-on, definitely check that out. And along with that, we have several other workshops as well. So be sure to look at that.
All right, excellent. Well, thank you both so much for being here today and presenting this really important topic that, again, really doesn't get maybe as much airtime as many of our other SaaS-related topics do, but every bit is important. And there's some good resources out there that I would highly recommend the community take a look at, like the workshop that Syed mentioned, and of course, the different blog posts and white papers that have been written that are available on our SaaS website through the SaaS Factory here at AWS. Thank you so much to everyone in chat that joined us here live today. I saw that there was some good interactions going on with Bill and some of our chat members, so thank you for that as well. And be sure to join us on our next episode of Building SaaS on AWS, again, a show where we bring you experts to talk about all of the various aspects of SaaS. A big thank you once again to Peter and Syed for being here. And to everyone out there, have a great day, and we'll see you next time. Thank you.
Thanks, everyone.
Thank you.